Thursday, 10:30 to noon. Come on up to the virtual school up here inside BHS and enjoy some board games with us. So, all right. I have a lot to cover today. I'll tell you. Yesterday should have turned in 3.01, 3.02. First two lessons in Module 3, which is all about solving quadratics. We're in the whole quadratics unit right now. Lot 2 quadratics, more than you've seen in the past. We're going to go through it a little faster than we did in Algebra 1, back when that was, and all that good stuff. Goes a little faster, but we're adding more to it. All this fun stuff with Algebra 2. So we'll be going through that. To this week, we have lesson 303, 304, 305. So we've got a lot of lessons to go through today. Because 303, 304, 305, all due today. So before we get into that, I want to get real with you guys. I'm a sharer. I like you guys to know what's going on, right? And I know, and I haven't given this speech this year, but I know that life happens outside of our virtual walls here. Life happens out there that affects life in here sometimes. It just does. We all have that. And that's what's happening with me. I have life happening out here that's affecting in here somewhat. I had a blood result test come back last week to say my leukemia might be returning. They found very, very small traces. Like they looked at like 125,000 blood cells, and 111 of them showed traces of leukemia. In the last 3.5 years, it's been undetectable. Now it's detectable. So last Friday, I went back and had blood drawn again, and they're running the test again to double check all of that. But it'll be a week or two before it goes back. It takes a while to count that many cells, I guess. I don't know. But it's a very slow process. It took like 10 days to get that test back the first time, which normally the test just comes back not detected, but that's not the case this time. Come back with detecting some leukemia, which may mean my bone marrow transplant is trying to fail, which is nearly unheard of after 3 years, but not entirely unheard of after 3 years. So we will see what goes on with that. In the meantime, I am experiencing the same symptoms I had 3.5 years ago when I was first diagnosed with leukemia. I'm having joint pain. Like right now, my shoulder blade back here is killing me. I don't want to move this arm very much because it's just like in a bind back there. And over the weekend, I didn't come to school up on Friday because I couldn't hardly walk. My hip was hurting like real bad arthritis or something. I don't know. My hip hurt every time I moved it or even when I didn't move it. And nothing can make it stop. And that's the symptoms I was having the first time. I would have joint pain, my knees, my back, my hips, my shoulders, and it would just constantly keep moving around, and no one could figure out why anything hurt. And that's what it is this time. I haven't injured myself. I haven't done a lot of strenuous things that should make any of those joints hurt. But I'm having a lot of hip pain and a lot of back pain and this bad test result. So right now, don't know what it means. Don't know where it's going. I may just have to go back on my chemo pill that I used to be on and just deal with the side effects of a pill. That won't be so bad. Hopefully it won't get to where I have to redo the entire bone marrow transplant, which takes a big commitment in months because I have to be isolated for several months and all that stuff because you have no immune system whatsoever when that happens. And then you got to get all your baby shots over again and all that stuff like I've done before. And I don't want to have to take all my baby shots again. These things hurt, man. You don't want to lift your arms with those baby shots. I had those like 2 years ago. So I don't want to start over. But we'll see. Let the doctors do their things. But I just want to be real with you guys because there could be times that affects us in here. You may come to class and find out Mr. Brock's not here to teach a class today because of whatever other things are going on. So we will see. We'll see where that leaves us. In the meantime, today, it leaves us with a lot of math to do. So we've got to look at this week's lessons. 3.03, sum and difference of cubes. All right, we've looked at difference of squares, right, where we factor different squares. Like x squared minus 9, which would be x squared is a square, 9 is a square. That would factor to x plus 3, x minus 3. Now we're moving up to cubes. So let me put this up on the screen. Wonderful. All right, let's talk about sum and difference of cubes. Now, a cube is like something to be like x to the third, right? That's a cube. It's something times something times something. Sometimes itself 3 times. You know, when we talked about the difference of squares, difference means subtract. Difference means subtract. With cubes, we talk about the sum and the difference. Sum is when you add, right? So we can add or subtract. So let's do a subtract one. When we do, just talk about this one right here. This is the difference of cubes. These are both cubes. This is x times x times x. This is 3 times 3 times 3. Right? 3 times 3 times 3 is 27. So both of these have a cubed root. So this has a cubed root of x. This has a cubed root of 3. I'm going to put cubed root right in the middle. Cubed root. So the way we figure out the factors of this, you know, this was real nice. You just said, okay, if it's squares, we take 2 x's, we take 2 3's, make one a plus and one a minus, and that's the factors when you have a difference of squares. We do something similar when we have cubes, and it doesn't matter if it's added or subtracted, sum or difference. In this case, it's a difference. So what we do is we find the cube root, and then we square it. Square it, which means this becomes x squared, and 3 times 3 becomes 9, right? Or negative 3. If this is actually a negative 27, so the cube root's actually negative 3. And when we square negative 3, we get a positive 9. So with that, we can now take this x squared, and we're going to have 2 factors in this also, but this is going to factor into a binomial and a trinomial. So we're going to take this x squared and put it in the first one. And we're going to take this 9 and put it in the last one. And then over here, we just take the cube roots, the x minus 3, and in the middle, we multiply them together and make them a 3x. This is a plus 9. But the sign is always going to be the opposite. Since that was a negative 27 at the top, this becomes a positive. So let me highlight that difference. This is a negative, so this is a positive. Opposite. Okay, these are going to be opposite. Highlight it in the same color. These will be opposite. These, however, are going to be the same. Same. So the binomial, the little piece, is the x minus 3. Same sign, x minus 3. Then we're going to take that x and the 3. We're going to make x squared and a 9. And then we're going to multiply them together right there and make a 3 and an x, 3 and an x. But we're going to check the sign to make sure it is the opposite of the original. So that's a pattern that we use. There's a definite pattern that we are allowed to use when solving the sum or difference of cubes. So here's what the pattern is, just as a general rule. Okay, general rule. So let's say the sum, if you're a note taker, here's the pattern. Here's the pattern. It just helps you solve it without having to do a bunch of math. If you have a to the third plus b to the third, in this case, x to the third minus 27 could be a plus, but this is the plus. So then the pattern is it's a plus b times, and this is found in the summary of lesson 3 also. A squared minus a times b plus b squared. close my parentheses. I almost didn't get my squared in the parentheses. Take the a and the b, make it a plus b. A squared and b squared go in the front and the back, whatever the a and the b are. Now remember, these are cubed. So like this, we say, well, 27 squared? No. Whatever we cubed to get 27. We got to take that cube root, right? So that's negative 3 to the third power. We would write this as x to the third power minus 3 to the third power. To make it look like this, because 27 is 3 to the third power, or negative in this case. Right? So whatever it is to the third power, you got to use that cube root as your b. Here's the difference when they're subtracted. Okay, so here is the pattern for that. You have a to the third minus b to the third, and that's going to equal a minus b, a squared plus a b plus b squared. Notice again, the difference is when this is plus, that's minus. When that's minus, this is plus. Otherwise, it's the same pattern. And this is the same. Right? So if it's the sum or difference, doesn't matter as long as you remember these are the opposite signs. And these are the same signs. But here's the tricky part. When you look at this 27, you got to figure out what is the cube root. You look at this x to the third power, what is the cube root? Don't just go straight with that 27. Remember that down a little bit. Don't just go straight with that 27. You got to do the cube root. All right, so don't get stuck in there and think the wrong thing. So let's try one that's a little more complicated than perhaps 3x, x to the third minus 27. Let's do something like they might give you in this lesson, or a problem that'd be a little bit more complicated. Okay, so let's look at 2x to the 9th minus 432y to the 6th. Okay, so there's three steps. One step right here. Greatest common factor. Step 2, cube roots. The 3, use the pattern. One of these patterns. Find the greatest common factor, pull it out first, then find the cube roots, then use the pattern. Okay, so let's try this. Greatest common factor, 2 and 432. Well, the greatest common factor here is 1 and 2 is all that multiplies that. We can divide that by 2 because it's an even number, since it's even. So this we rewrite as 2x to the 9th minus, and then we divide that by 2. So it'll be 216y to the 6th. Probably ought to have my calculator handy. We might get into some calculator math today. All right. So we'll make it into some calculator math. We'll have it handy right here. So now the question we got to, first we found the greatest common factor. That's it. We pulled the 2 out. We divided 2. So now we're looking inside here. We have to find the cube roots. So what will multiply by itself 3 times to equal x to the 9th? Okay, so the cube root of x to the 9th will be x to the 3rd, right? Because x to the 3rd times x to the 3rd times x to the 3rd will be x to the 9th. Negative 216. Is there anything that multiplies by itself 3 times to get negative 216? Well, if you don't know, you can always try. And you can try it with, let's see if I can do this without, well, these lights over the top are a booger. Let's put it over here. That's a little better. Light doesn't hit it so bad. So if you're not sure, try numbers. 4 times 4 times 4. Well, that's 64, so that's not big enough. 5 times 5 times 5. 125, that's not big enough. 6 times 6 times 6, 216. Hey, that's what we were looking for, 216. 216. So we know negative 216 is negative 6 is the cube root. Because if I do negative 6 times negative 6 times negative 6, I'll have negative 216. And y to the 6th would be y squared. So these are the cube roots. First, we found the greatest common factor and pulled that out. Now we found the cube roots of this. All we have to do is use the pattern now. Okay, so if we have, this is a difference. This is a difference. So this is going to be, we have the 2 out front. We didn't have it up here. We factored out a 2. So that has to be out front. But now that we know this would be the A, this would be the A, and this would be the B in this pattern. Our A is x to the third. Our minus b to the third is minus 6y squared. So A minus B. So x to the third minus 6y squared. Remember, this should have the same sign. It's a subtracting. It's a difference. It should have the same sign. The other one is this pattern, A squared. So x to the third squared, which should be x to the 6th, because a to the third times a to the third is a to the 6th, plus, so there should be a plus this time, because we're doing a difference one, a times b. We multiply these times each other. 6 x to the third y squared. 6x to the third y squared. You can put those in any order, but generally the proper way to do that is to list it alphabetically. X comes before y, so we'll list the x variable before the y variable. I mean, it's not wrong to say x to the third 6y squared, but to list it properly, we should have the coefficient followed by the variables in alphabetical order. The last thing is to square the b. Square this. Negative 6 times negative 6 is a positive 36. Y squared times y squared is y to the 4th. That's our answer. That was the original problem. First, we found the greatest common factor. Then we identified the cubes. Then we used the pattern to write the answer. Did we want to do another one? Let's look at one more. Let's look at one more. Do the same thing. Greatest common factor. Find the cubes. Use the pattern. Okay, this time we're going to try 64 y to the third minus 729 z to the third. Woo, okay. So first we're going to have to find factors, greatest common factors. So we need to figure out what all factors is 64. Okay, so let's just jump down here and do that separately. 64, that's the same as 2 times 32. And 32 is the same as 2 times 16, which is the same as 2 times 8, which is the same as 2 times 4, same as 2 times 2. So really the factors of 64 is 2 times 2 times 2 times, that's the prime factors. The prime factors is 6 2's multiplied times each other, which means any other factors you can combine in there. 2 times 2 is a 4, so a 4 would be a factor. 2 times 4 times 2 times 2 times 2. Or an 8 or any of those. So any of these things multiplied by 2 is a factor. 2 and 32, or 2 2's and a 16, or 2 and a 2 and a 2 and an 8. You know, so we have lots of factors in there that we can multiply together. Let's look at 729, because that's the one that's a little more unknown to us. Let's see what we can use to find a factor 729. So 729 we know is not divisible by a 2. That's an odd number. But let's try 3. So if we divide it by 3, 243. So it's the same as 3 times 243. Okay, there's not a 3 over here, so we don't have anything in common yet. There's not a single 3 to be found. So let's see. This is still not divisible by a 2, so let's try a 3 again. 243 divided by 3. Oh, 81. So this is the same as 3 and 81. Again, nothing in common at this point. 81, well, that one we know, that's 9 times 9. And 9 times 9 is 3 times 3. So all the factors of this are 3's. And anyway, we multiply 3's together. 3 times 3 is 9. Well, we don't have any 9's over here. 3 times 3 times 3 is 27, but we're not going to get 27's over here. Everything over here is an even. Everything is even. Everything over here is odd. There is nothing in common. Nothing in common. So now the question is, what number is this? This is the cube of something, perhaps. What is the cube root? What is the cube root of 64? Okay, so 64. Well, let's see. 3 times 3 times 3, that's 27. 4 times 4 times 4, 64. So 64 is one of our cubes. It's 4. And y to third. So 4y is one of the cubes. There were no greatest common factors. So now we're trying to find the cubes. 64 third is the cube of 4y. Right? This is the cube root. Cube root right here. 4y. How about 729? Wow, let's see. 5 times 5 times 5, we said was, oops, delete that. 125. 6 times 6 times 6 was 216. 7 times 7 times 7 is 343. 8 times 8 times 8, 512. 9 times 9 times 9. Maybe it wouldn't be bad to make this in your notes. 4 cubed is 64, 5 cubed is 125. It may save some time if you're doing many of these. Oh, 9 times 9 times 9 is 729. So this is negative 9z. That is the cube root. Yeah, let's get this out of the way. Get the light back here, right? So negative 9z is the cube root of negative 729z to the third. So there's our cube roots. Now our pattern. So our pattern said we take the a and the b and we do the same sign first. All right, so that's the first factor. We didn't factor anything out. We don't have anything in the front. We did not have a greatest common factor. So we don't have to worry about putting anything out here. Then it said to take a squared. So 4y times 4y is 16y squared. Right? That's 4y times 4y. 16y squared. And then it's supposed to be the opposite sign. Remember, plus, and we multiply these times each other. 4 times 9 is 36. YZ. Now we ignore that negative because 4 times negative 9 is actually negative 36, but we know the pattern. The pattern tells us we have to be the opposite sign. The pattern. We'll go by the pattern. And then the last one is 9z, negative 9z times negative 9z because we're squaring that. Negative 9 times negative 9 is 81 z squared. So this is plus 81 z squared. There you go. That is the factors of this cube up here. Difference of cubes. No greatest common factor. We found the cube roots. Cube roots. And then we applied the pattern and got the answer right there. So that's what lesson 3 is all about. Factoring cubes. Factoring cubes right there. All right. Let's move that out of the way and look at lesson 4. Lesson 4 is back to quadratics. So we're back to just x squared, but it's about graphing quadratics. Graphing quadratics. Now, one thing it talks about right off the bat is the vertex form of a quadratic. Now, we're used to the standard form. The standard form is ax squared plus bx plus c. And usually we'll say it's like equal to 0 or whatever, but that's f of x. That's what we're used to, right? Ax squared plus bx plus c. That's when we see a quadratic. But the vertex form is f of x equals a parentheses x minus h squared plus k. We can do the same equation in either form, but this form tells us something. It tells us the vertex. The vertex is like when you graph it, we know that quadratics make a parabola. The vertex is the lowest point, or if it's an upside down one, it's the highest point. But it's the turning point. That's what the vertex is. So since this is the vertex form, the vertex, when we see this in vertex form, is HK. Whatever that H is and whatever that K is the vertex. So for example, if we had f of x equals negative outside the parentheses, x minus 2 squared plus 9, that would tell us that the vertex is not negative 2 because there's a negative up here. With the negative, you just take the h. If there's a negative, just take the h. If that's a positive, that means the h is negative to make that a positive. So since it's minus, the vertex is 2, and then whatever the k is. Our k is a plus 9. Our vertex is 2, 9. Since there's a negative out front, that actually means that ours is upside down. But we know that this point here is 2, 9, and that's going to be the turning point. So that means that its maximum value is at 2, 9. The other thing we talk about with, and I didn't draw that one very symmetrical, is when we have a parabola, they're symmetrical, right? You have that axis of symmetry. You should be able to take this line right through the vertex and draw a straight up and down line. And it looks like a mirror on both sides. Looks like a mirror on both sides. So you should have that axis of symmetry. And with the vertex form, turn that lighting down a little bit. With the vertex form, it's whatever the x is. Like on this one, be x equals 2. That's the axis of symmetry. That would be this line right there. That would be symmetrical. For this, whatever the vertex is. Be the, this is the xy, which x equals whatever that number is there, is the axis of symmetry. So those are the important things when we're graphing quadratic equations, is we need to know the vertex and the axis of symmetry. Those are important features to know, because it allows us to graph that if we know those things without doing a whole lot of other work sometimes. When we look at the domain is all the possible x's that produces a unique y. When we have a parabola that's up or down like that, the domain is negative infinity to infinity. There's no places that we have to worry about two y's being assigned to the same x. The range depends. On this one, the range is everything from the vertex up. Every y could be up there. It could never be a number below that vertex. Or this one, this 9 is the range. Negative infinity to 9. 9's included. Because it can go up to 9 and everything below 9, but it'll never be any higher than 9 because it's an upside down parabola. Upside down parabola. So we learn a lot when we graph it. We can do domain and range, and we can do maximum and minimum, and we can do the axis of symmetry, and we can do the vertex. All of those things tell us a lot. So, and the vertex forms helps us to pull out that information very easily on there. If we have in regular form, in standard form, we got ax squared plus bx plus c, and we want to know this axis of symmetry. There's a formula for that. The axis, here's the formula. X equals negative b over 2a. Negative b over 2a. So let's give an example. If our f of x is x squared plus 6x plus 8, our axis of symmetry would be negative B, which is 6 in this one, right? Because 6, the B. And what's our A? Our A is 1. So 2 times 1, 2 times A, 2 times 1 is 2. And that simplifies to negative 3. So x equals negative 3 is our axis of symmetry. I say, okay, great, but that tells me something. But what about the vertex? This is not in vertex form. No, but if I know the axis of symmetry, the axis of symmetry always goes through the vertex. So I know half of the vertex already. It's at negative 3 something. Well, how do I find what the something is? I have the formula. I need to know what is y. Y would be, I'll substitute in negative 3 for x. What is the y when the x is negative 3? Plus 6 times negative 3 plus 8. So this is negative 3 squared is 9. 6 times negative 3 is minus 18 plus 8. Getting off the page, aren't I? So if I substitute that negative 3 in there and solve this, 9 minus 18 is negative 9 plus 8 is negative 1. So my vertex is negative 3, negative 1, because that is what the equation equals when x is equal to negative 3. So that means that will go through the point negative 3, negative 1. So even from standard form, I'm able to pull out the axis of symmetry and the vertex, knowing this axis of symmetry formula right here. Let me highlight that one. X equals negative b over 2a. All right, that's the axis of symmetry. Great to have that in your notes, that's the axis of symmetry. Save you some time trying to dig all that out. Okay, let's spend some time talking about lesson 3.05, because that one could be a little trickier. It's completing the square. And you should have seen this back in Algebra 1, but I know that's been a while. And completing the square is a skill that if we don't use it very often, it's easy for that to get pretty rusty. So let's get a fresh piece of paper over here and talk about completing the square. So if we want to have a quadratic equation and we want to convert it from standard form to vertex form, all right, so we're going to convert it. We have to do that by completing the square. So let me find a good example here. Oh, well, let's use the one we had because we know what the answer is. So if we get it wrong, we'll do x squared plus 6x plus 8. X squared plus 6x plus 8. We know what the vertex should be. So that way we'll know if we mess up any of the steps. All right, so we're going to change this to y first off, so we can do some math with it. Remember, same thing, f of x or y. The first thing to do that is we're going to isolate everything with an x, which means we're going to get the 8 to the other side. This is y minus 8 equals x squared plus 6x, right? X squared plus 6x. And to complete the square, we factor to make sure that the leading coefficient is a 1. It is. This is a 1. If this was like a 2x squared plus 12x, we'd want to factor a 2 out, or whatever the coefficient is. But this needs to be a 1, which it is. So once we've done that, okay, and these steps are in the summary. So when you go through this lesson, you'll go through these steps. Then you can watch this if you need a refresher. Now we're going to take the coefficient of the x. This is the x. This is the x squared. This is the x. The 6. So we're going to take the 6 and we're going to divide it by 2. 6 divided by 2 is 3. And then we're going to take that number, whatever it is, and square it. 3 squared is 9. So what I'm going to do is I'm going to add that 9 on the end. I can't do that unless I add 9 over here also, right? If you do it to one side, you have to do it to the other side. I add 9 to both sides. Now I just simplify. Over here, I've got y. I've got a positive 9 and a negative 8. So that's y plus 1. And over here, I've got the x squared plus 6x plus 9. Now, I know because I made it this way that this is a perfect square trinomial because I just made it a perfect square trinomial. We looked at that in an earlier lesson. A perfect square trinomial means this is the same as x plus 3 times x plus 3. I just figured that out because I cut the 6 in half and made it a 3 and then squared it. So this factors to this. So that means this is the same as x plus 3 squared. And if I subtract 1 from both sides, that's minus 1. So here is the equation in vertex form. So remember, it's x minus the h squared plus k. This is plus 3. So x minus a negative 3 would give us x plus 3. So this must be negative 3 for the h. And the k is just whatever this is, which is negative 1. Over here, we calculated the vertex is at negative 3, negative 1. So we must have done this correctly because this vertex form says that the vertex is negative 3, negative 1. And we did it by completing the square. Okay, now completing the square is not an easy thing to remember how to do. We have to practice over and over and over again. If you don't practice it, it doesn't stick in your head. You don't remember it, and you go to do it in your test, and you're like, oh, I don't remember something about you take some number and you square it or you cut it in half or something like that. Practice it. Let me tell you one other thing. If you want to find out what kind of solutions you have, negative b plus or minus the square root of b squared minus 4ac. Don't ever forget when we're working with the quadratic formula, the quadratic equations, that you have the quadratic formula. This is the quadratic formula, right? You can always solve quadratic equations with the quadratic formula just to find out what the solutions are. But it won't give you the vertex form and stuff. It just tells you what the solutions are. So if we're trying to find solutions at some point, it's important to remember when you're solving that this underneath the radical is called the discriminant. Discriminant. And the discriminant can tell us a lot of things. Using the ax squared plus bx plus c, the standard form, ax squared plus bx plus c, that's how it has to be, equal to zero to use the quadratic formula. If we plug in the b squared minus 4ac, it will tell us what kind of solutions this has. That means where does this cross the x-axis? When is it 0? So looking at this, our b is 6. So let's check the discriminant. 6 squared minus 4, a is 1, c is 8. Okay, so 6 squared is 36. Minus 4 times 1 is 4. 4 times 8 is 32. So this is 4. Okay, so this tells us two things. First off, it tells us that there are two solutions. And since this is a perfect square, it's 2 times 2, that means they're both rational. With your discriminant, if, make a chart here, if the discriminant is 0, you'll have one rational solution. What's rational means? That means you can write it using a fraction. This is 2 over 1, really. 2 and negative 2 is your answers. One rational solution. One rational solution. If you have a greater than 0 answer when you do this, if it's a square, you have two things here. Perfect square, which 4 is a perfect square, that means two rational solutions. If it is not a perfect square, but it is greater than 0, it's not a square, that means you'll have two irrational solutions. which mainly means the answer is like 2 plus the square root of negative 3 and 2 minus the square root of negative 3, or something something you can't write with a fraction, but it'll be some number. And that's when it's greater than 0. If it is less than 0, and we're talking about the discriminant, when you evaluate this, if it's less than 0, that means there's 2 complex solutions. That means they have imaginary numbers. Could be, 2 plus 3i and 2 minus 3i. It might be your solutions. So this discriminant, when you use the quadratic formula, tells you what kind of solutions you have. And then you can use that whole formula to find those solutions. But if you just need to know what kind you have that. So that's also part of lesson 5, is using the discriminant to figure out how to do that. So you can solve a quadratic by completing the square. You can create it to the vertex form, completing square when you get there. Lots we can do with the quadratic formula. You can do all kinds of stuff. Don't forget the vertex form tells you a lot, tells you the vertex, tells you the axis of symmetry. And then we also had the cube lesson that we did. But here's the secret. Here's the key to these. And there's a lot of information, especially this completing the square. If this is how you go through the completing the square lesson. Okay, so then I do that. Then they want me to do that. Okay. Now it says, what's the cube roots? Here, let me click and see. Okay, it says 2x squared is one of the cube roots, and negative 6y is the, okay, that's the cube roots. And then I'm supposed to square the, okay, I'll square those and put them in the pattern. Okay, I see what I do. Okay, but where's the next one? What do you do? Okay, greatest common factor. All right, what is it? Click. Oh, yep, that's the greatest common factors. If you're doing the whole lesson that way and watching and seeing that all those problems worked, you're not going to remember very much. You're not going to learn the math. The way you learn math is to do math. The way you learn math is to do math. The way you should do these lessons, this lesson especially, lesson 5, but any of the lessons, you should do it with a piece of paper right here. And you say, okay, it says find the greatest common factor. Let me write that problem down. Okay, greatest common factor. So the greatest common factor should be this, and I think it's the, okay, I think that's it. Now let me click. Oh, that's not what they got. What did they? Oh, I forgot about that. Let me fix that. Okay, now it says find the cube roots. Okay, so for that, the cube root is this one. For this, cube root's this. Now let me click. Okay, I got that right. All right, now what do I need? Okay, now I just go, okay, next step. And see, if I'm doing it first on paper, and then I'm clicking and let the lesson tell me what the right answer was, I can check to make sure I know what I'm doing, and I'm doing it right. And then as I go through and I do all those practice problems, I've already got them on paper as I'm doing them. I know they're right because every time I do one, I can click on that button. It pops open and shows me what I should have got. Great. So by the end, I'm probably not having to double check very much because, yep, that's right. Yep, that's right. Yep, that's right. The beginning's when we're making mistakes. So by the time you get to the quiz, by the time you get to the test, easy stuff. You've already got these notes that you can use on the quiz and the test. Oh, yeah, I did 5 of those problems. Let me find them. Oh, yep, here they are. Oh, that's what I do. That's what I do. That's what I do. Okay, so let me do the new problem on the test. Boom, 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 boom. That's it. Perfect. That one gets real easy. Use your notes on the quiz. Use your notes on the test. But the important thing is to be using the notes as you go through the lesson. That's when you're creating those notes, that you're writing those problems down, that you're solving that before you're clicking and see what they solve it. If you're just watching someone else doing math, they're learning math, you're watching. You're not learning it. You're going to struggle. You're going to get the test and go, oh, what did we do? I remember we did something on that. Let me see. Okay, I think it's this. But you have no idea, really. So do the lessons correctly. You should do all the lessons that way. But very importantly, make sure you do the completing the square lesson. Because completing the square is not intuitive. It doesn't come easy. But once you start doing a few of them, then you're like, Oh, okay. Now I understand it. Now it's easier. Now it's easier. And it just gets easier and easier the more of those you do. So pretty soon it's like, I don't know why this seems so bad at first. It's pretty simple once you get the hang of it. If you don't practice it, it's always going to be hard. Every time you do it, it's like, oh, I hate these completing the squares. I'm no good at them. I'm saying, well, that's because you haven't done a lot of them. Then you have hardly spent any time trying those. That's what I'm trying to get into. If you want to learn this stuff, you got to use the lessons the right way. Buzz is great for giving you opportunity to see what you know and see what you know and see what you know. So by the time you get to the test should be the easiest thing you do in the whole unit. It'll be the absolute easiest thing you do in the whole unit. So, all right, I'm not going to throw any more at you today. We have a lot in those three lessons, especially the last one. The last one gets be quite a bit in there. So if you have over 70%, I won't see you the rest of the week unless you have questions.
Let's get out of here. Word to your multiples. Math, baby. We're learning math, baby.